All right, lesson 56, which is circles, and obviously a good time. We have lots of theorems we have to learn here, and lots of terms and definitions. I'm sorry, was that excitement I heard? All right, lesson 56. So we have a circle, and we have what you would call a minor arc. So when we're talking about an arc, the measure of an arc of a circle is the same as the measure of the central angle. So let's take some figures here. If we had 70 degrees, then the measure of this arc is also 70 degrees. I mean, that's awesome. That's easy. So that would be a minor arc. And then the measure of the rest of the circle would be what?
290.
Great. And that would be a major arc. Easy so far. When two arcs are not equal, this is the only definition. When two arcs are not equal, we call the longer arc the major arc and the smaller arc the minor arc. Okay, no biggie. Also, with the circle, we have three words that we are going to be using a lot. Oh, that's a pretty bad circle. We have a secant. A secant goes through the circle. We have a chord. The chord goes stays on the inside of the circle from one end to the other, and then we have a tangent. And a tangent just touches the circle at one point. So this is all new vocabulary, but it's important because when we're describing the theorems and everything, we don't want to say that line that touches it at one point every time. It's just a waste of time and space. And who has extra of that? Not me. All right, so we're also going to remember a previous theorem where we have a circle. Got all these markers in my hands now. And we have an inscribed angle. Do you remember this?
A little bit.
A little bit. We remember that the measure of the inscribed angle is going to be half the measure of the intercepted arc, right? And if we had a central angle, are you kidding me?
Alright, so
Happy New Year, it's
Happy
good to
New
see you.
Year's.
Okay, I'm so excited. All right, 280 degrees. So the central angle is the same as the intercepted arc there. Now is when we add a new one, or a couple new ones here. If you flip to page 242, do you need a book?
Yeah.
It's your lucky day. I have one. Page 242. Read that top paragraph for me, Nick.
If two lines intersect inside a circle, the measures of the angles formed equal 1/2 the sum of the measures of the intercepted arcs. If the lines intersect outside the circle, the measure of the angle formed equals 1/2 the difference of the measures of the intercepted arcs.
All right, let's focus on a couple of the words there. What's different from one to the other? You mentioned two theorems there. We've got
Wait, we're on page 242?
242, page 242. We have two circles and we have lines, right? The first situation, the lines, where do they intersect? Inside
the circle.
the circle. The second situation, the lines intersect where? Outside the circle. Now you may say these lines aren't intersecting, but they are. Just they don't keep going. That's their point of intersection. Okay? So if the lines intersect inside the circle, what's the difference between if they intersect outside the circle? Can you see it in that first?
I don't think.
Where are you? Are we in a different book? 242. That's, wait, what?
Oh, yeah, it must be a different edition.
It must be the different edition.
It's 56.
So we're on lesson 56. And, oh, this is really, is this your book? Because you had a different edition, right?
This is
How did this happen? All right, there we go. This is all being videoed, so it's very exciting. All right, so the two lines intersect inside the circle. The measures of the angles formed. Here's the measures of the angles formed. Let's have another color here. The measures of the angles formed are, what do we do? Equal 1/2 the sum of the measures of the intercepted arc. So these angles are going to be the same. We know that because they're vertical angles. And whatever that is, x, we'll say, it's going to be equal the sum of, sum means add, right? The intercepted arcs, let's say 40 and 80. And it says measure the half the sum of the intercepted arcs. If the two lines intersect outside the circle, then the measure of the angle, now there's one, equals what?
1/2 the difference of the measures of
Yes,
the
so
intercepted
1/2,
arcs.
it's still divided by 2, but what's different?
subtract.
Yeah, difference, get
Ah.
it? Thank you. So now this, and this 40 degrees refers to the arc measure here, 40, and, well, this is not a very good drawing, but you'll just have to use, we'll say 60, we'll use different numbers just for fun, because otherwise the 80 seems crazy. So now we have the difference, and you take the larger one. There. So they intersect inside the circle, you add them, divide by 2. If they intersect outside the circle, you subtract them, divide by 2. Any complicated math there? No. We just have to remember, inside you're adding, outside you're subtracting. All right, and that is for one of our theorems. Another one has to do with exterior angles versus interior angles. And we're not going to get into the proof of that because we're running out of time. But they show you the proof there, which I'm sure when you're bored tonight you will want to take a look at, right?
Yes.
But basically what it boils down to is if you have an exterior angle like this, it is equal to the sum of the two remote interior angles. When I say remote, it means not that one, okay? So angle 3 equals angle 1 plus angle 2. And you can just write that down. So looking at practice problem A, I wish I didn't erase the other pictures, but I guess we can do them real quick here. X equals A plus B over 2, and then X equals B minus A over 2. All right, so looking at A, practice problem A, we would have what? X equals,
80 plus 60.
Yeah.
Over 2.
80 plus 60 over 2, which is 70. Yay! Math's easy and fun, don't you think?
Sometimes.
Sometimes, okay. B, Nick, what about that one?
For B, we have the outside angles, right?
Mm-hmm. So X equals,
It's 1/2 the difference of the measures of the intercept arcs.
right, the difference. You just take the larger one, 80 minus 60 over 2, which equals what?
10.
That's right. Okay, C is the exact same. C would be X equals 70 minus 20 over 2, and D would equal, looks different, but it's the same. X equals 280 minus 80 over 2. Great.
Seems too easy.
You know, you're just too smart. That's it.